Hello everybody, it is Tuesday the 24th again, and to our second worksheet. If you're staying up with things, you did FM22 yesterday. So once again, I will proceed on, try to do this more expeditiously on the actual worked out key as opposed to doing it from scratch. And I'm curious, since if you looked at yesterday's, the FM21 video I just made a second ago, then how's this working? Would you rather do it slower and step by step and me draw it out step by step like you do in class, or is this good? If you have thoughts, go ahead and post them probably in the collaboration space under FM22. Tell me if these videos are helping and if you'd like it faster or slower, etc., etc. So, oh, and by the way, I'm going to probably send an email announcing these videos on the pages now, but that in terms of testing on this stuff, I have no idea. We'll see where we go. I know it's coming up reasonably soon next week according to the calendar, but I'm not sure how to do that. So we're going to be talking about that in our MS Teams meeting that we have for the math department. So we'll see about that. So now at it. So building off your yesterday, inverses. We have the S of x function, then we have the inverse S of x function over here. Notice that I did the original function in blue, and I got my blue graph, and then x and y swap roles just like they do with any inverse. So the other thing to notice on this, notice that I have a horizontal asymptote. Well, anyway, my vertical asymptote is going to be equal to x equals -5 on this, and my horizontal asymptote will be y equals 3, correct? Now, notice that, once again, these swap roles here, I'll do it in pink, that this is now an x equals 3 vertical asymptote, and this becomes a y equals -5 horizontal asymptote. So, not only do the x and y swap places, swap roles, the vertical asymptote swap roles in the inverse here, and that really makes it easier to graph. Taking the points that I've already developed for my my one rational graph and just basically flipping them around and graphing those points is almost easier than even working with the equation. Kind of gets me half the way there. Notice again, in this case, the domain for the original function, x not equal to -5, notice that that is become the range for my inverse, and likewise the range of y not equal to 3 ends up becoming the domain. So everything's, x and y are swapping roles on all kinds of parts and pieces. Okay, that's cool. Now, how did I get this inverse function in the first place? Our three-step process. And I guess I'll use my little mouse right up here. The S of x, the y, took the role of the S of x just because it's easier to swap x and y when it's y equals. And then down here, y became an x, and x became a y. And then that was my first step. So everywhere there's a S of x, put an x here. Everywhere there's an x, that became the y. And then the second step is to solve for the new y. Now, it's a little bit more tricky here, so I got to subtract 3 first. And then where you want to think about this is cross multiply or whatever to solve for the new y. And then the new y becomes s -1 of x. And lo and behold, I have my inverse function. Same deal. It looks like on the key here, I only did s, the original function s of the inverse function. To prove it, I really should be good and do the s -1 and then plug in the original function into that and compose it both ways. I really should do the original of the inverse and then the inverse of the original both ways. I won't take the time now because I'm thinking you probably like these talks a little bit quicker. Besides, they're so big when I upload them. Okay, so hopefully that, was just a summary of what we did yesterday, some key points. The point of this section here is that all different kinds of equations have inverses, and to see this in summary form. The inverse of a linear is another linear, as you can see here. Inverse of a quadratic is a radical. That's the one we did yesterday right over here. An exponential function, which we haven't done as much, we will be doing very shortly, and this is the actual bridge that helps us do this lesson. The exponential function, which is the blue, looks like this is an exponential growth function the way I drew it. If you flip that over the y equals x line, becomes the green logarithmic function. Guess what we're doing in our next unit? Likewise, we just did, polynomials and cubic. So we get an S-shaped curve, and you flip it over the line y equals x, and it became the green cube root function. We just did those recently. Rationals, another rational, and radical, of course, the quadratic. So this is just summarizing of the look and feel. Notice every one of these is a reflection across the line y equals x. Okay, down here, it looks like just basic function operation. Shouldn't be anything new here, really. I'm not sure why we did this. Just basic. When you're adding functions up, don't forget. I guess this goes hand in hand. If I have f of colors, g of x, don't forget that I can write this as f of g of x like that. One more notation. Sushi dinner thing. The thing that most students do with these is they like to do both operations at the same time. So the cost after the coupon, they're actually doing taxing at the same time. The way the composition with these is intended to work, the cost C of x function, cost after coupon function, ignore tax. And basically 10% off, you have the original price. 100% of x minus 10% x means you're now paying 90% of the original cost. Fine. After taxes, 7%. Hopefully you can see that it's 1.07, 107% of the original price kind of thing, which is the 100% of the original price plus another 7%. And then composing means in real life, let's see what this would mean. I do my coupon after taxes. I take the calculate taxes first, do work from the inside out on these things. Hopefully you can see my little mouse. And then I do the coupon after that. And composing rules, 0.963x. Fine. The other way, T of C of x, means I first do my coupon, and then after I do the coupon calculation, then I take my taxes. Hey, it's the same answer. Now, it's not always going to be the case. I'll let you think about what would happen if instead of a coupon that was 10% off, let's say the coupon was $5 off. Would it matter which one came first then? That's interesting. Okay, down here. I don't know why I scratched this out last year in this key. There's two ways to do these. Let's focus on this one right here. Nah, not in blue. Let me do pink because it highlights better. This C, because it looks like I started to work this out here. There are two ways to do this. Notice that I did g of 2, h of g of x, g of 2. Fine, take 2, plug it in the g function. 2 squared is 4 plus 14, 18 plus 12 is 30. Then the answer to that is 30. G of 2 is 30, so h of 30, and then you get 86. You'll simply work with a number. That works fine. And that's probably the easiest way to do these with numbers. Or I could actually compose a function and do a h of 3. Again, when I'm composing, I like to open up big old parentheses, and I'll do my g function in green here, and I'm going to take that and plug it into here. So g of x, and the g of x function is x squared plus 7x plus 12. And then I would work all the algebra to simplify this out. I'd have a single function, and then I could plug 2 into this resulting function that comes from that. This will take longer, but if you got a lot of points to plug in, well, then you can do that. But so usually when you're working with simply like h of g of x or numbers themselves, you simply put it in that format. You simply just do the number if you're working with numbers. Okay, well, anyway, I think that'll be enough for this thing. I think it's reusing the same ideas from the FM21 worksheet a lot, so I'll say goodbye. Bye.